Okay, so I apologize for not getting this posted earlier, but again, for some reason this week I have been beset with technical difficulties. Even as we speak right now, I'm recording on my MacBook, which is balanced on the back of my desk chair. Very unstable. I fully expect this to fall while I'm recording. Good thing MacBooks are cheap. Well, I didn't pay for it, the department did. That's a joke. I mean, the department did pay for it, but I'm not that glib with their resources. Anyways, okay, so we are talking about Greek mathematics. Now, we just gave a very surface level view of Egyptian mathematics, and obviously, we're just going to be able to give even more of a surface level view, meaning even less deep of Greek mathematics, because it's so broad and there's so many things we could talk about, but we have such short time to talk about it. Now, the good thing is, once we start getting into Greek mathematics, we kind of, in the West, sort of trace our intellectual lineage back to there. So it's going to be very familiar to us, and it kind of lays the foundation for things that are more familiar to us. And so even though we're only going to spend this week talking about Greek mathematics, the influence is really going to be felt throughout the rest of this semester. And one of the ways that is most felt is in the Greek just way of doing mathematics. I obviously am not a history teacher. I'm not an historian, and so I'm not completely sure what to do with a whiteboard when I'm not putting mathematical things there. So just bear with me. I'm going to put what might be like helpful outline markers or something for this. But this one video, this one introductory video, will be very short. But one thing, what distinctions of Greek and maybe even Greek and Roman mathematics, what are the distinctions? They used a lot of stuff that came before them. They used Egyptian mathematics, mathematics from all over the world. Okay, so but in particular, Egyptian mathematics and Babylonian mathematics, they were influenced by in terms of like the facts that they possessed. But Greek mathematics took a slightly different turn. In some sense, it was done for its own sake. That is, instead of doing mathematics in order to create something, in order to solve some other problem, the size of a pyramid or whatever, just learning mathematics for its own sake was now seen as a valid pursuit. Not only valid, but like a noble pursuit. And I think this is like an interesting aspect of the human condition. Think of all of the different times, like writing, for example. Writing was first done in order to, account for trades or whatever. There's some practical reason to do writing, but now, look at all of the various different artistic things that can be done with writing. Novels, poems, whatever. And you can, I would imagine I'm definitely not an art historian, but I would also imagine if you think about various artistic things, paintings, sculptures, whatever, you can trace these lineages back to doing something practical, and then because we are creative and because humans are creative in the way that we are, we took these things which are at first used for practical purposes, and then turn it into just doing that thing for its own sake. Anyways, that's one thing. But another thing that distinguishes it is the use. Having trouble spelling here. Use of formal axioms. And propositions and so on and so forth. Okay, so for example, most of you are familiar with doing mathematics this way, and you think about Euclid as being this is kind of maybe one of the earliest examples that we have of mathematics being done this way, at least like big work. Though, as you will read In the book, we have no surviving copies of anything from of these original Greek mathematics. They've all been lost to time because they're all written on things that are very easily corruptible, especially in the climate of where they were happening. But we have, people relating these things afterwards. Okay, so I think one of the main turning points for this was with Plato's Academy. Okay, with Plato's Academy. Because what's happening in Greek mathematics is that Greek mathematics gets tied up and sort of, I don't know, we probably still have this. I mean, this is, Isaac Newton had this same concept. It gets very tied up with Greek philosophy. Okay, so how does that influence mathematics? So I'm about to say some names that I'm not necessarily good at saying. But you have one philosopher, Heraclitus, who is working in the 5th century. And there are probably people in this class who know more about Greek philosophy than I do, which is probably most everybody. He's working in the 5th century, and he basically says everything changes. Everything's in constant flux. Okay, everything is constantly changing. Okay, now we have another person who was writing who has existed a little bit before him, Parmenides. Wow. Sorry. Now he says only knowledge. Knowledge is only possible. Got that backwards. Knowledge is only possible for unchanging things. Okay, so we've got, this is 6th century. And notice I said he was before him, so this is BC here and BC there. Okay, so this is earlier than that if we're doing in BC time here. Okay. So anyways, we've got one person here, we got this person here first saying that knowledge is only possible for unchanging things. This person here says everything changes. So if you're trying to, if you're Plato or anybody else really, how can you synthesize these two things? Well, the way that Plato did it was with these things that probably you guys have heard before, Platonic forms. Okay, so these are like things that exist, these are the idealized versions of things. Okay, so let me give an example here. To kind of relate maybe what this means. Okay, so if I say something like lions are carnivores, if I make a statement like lions are carnivores, what exactly am I saying? Well, I should say lions. Well, I'm probably saying something like all lions are carnivores. All lions are carnivores. Well, what is grammatically speaking, like what is the subject of this sentence? It would be all lions. In other words, the set of all lions. Well, that's not quite right. The set of lions is not carnivorous. What this means, the way that we interpret this, is like each individual lion is a carnivore. Okay, but but this is also not a statement about any particular lion. Okay, it's not like we're saying that lion there is a carnivore, and that lion there is a carnivore, and that lion there is a carnivore. That's also not what this statement is saying. So what Plato says is that when we make when we make universal statements like this, what we're really doing is we're making a statement about the relationship between this Platonic form of lion and the Platonic form of carnivores. This is sort of an implication. This is an application of these Platonic forms. Now, how does that relate to mathematics? So Plato was very interested in mathematics because he wanted to try to get a theory of everything, right? This has been something that people have been trying to do for a very long time. So he wanted to try to get a theory of everything. And he thought that mathematical objects could somehow be a bridge between Platonic forms and the things that we have in life. So every lion is just a copy with errors of the heavenly, so to speak, Platonic form of a lion. Okay, mathematical objects though. Okay, there is a Platonic circles and an idealized circle that sort of meets the definition exactly. But we also have, we can draw circles, and that gets as close as we can to realizing this Platonic form. Okay, but one important thing about Platonic forms is that they are unique. Platonic forms are unique. Like there's a circle that is there's not like a storehouse of circles that we pull from, and then we have a circle, but in that process it gets distorted or something. These are like idealized versions. They are unique. Okay, but let's think about what this means. Like line segments, there could be a Platonic form of a line segment, but there's also a Platonic form of a triangle, which is formed by 3 line segments. So it seems to somehow violate the uniqueness of that. So this idea that we have realized concrete triangles that we can draw like this, and this connection to the Platonic forms, Plato kind of thought that this would that mathematics, in other words, could serve as a connection between these, idealized forms and what we actually, instantiate, or whatever you want to call it here. Okay, and so because of this, because this was he was obviously influential. Plato and his academy were influential in Greek philosophy and Greek mathematics. This is kind of where a lot of this part kind of comes from. This view that the Greeks had of mathematics comes from. And so we will talk more about Greek mathematics and the actual mathematics that they were doing, which is an area that I am much more comfortable with than this stuff right here, in which I'm like a hobbyist or something, but I'm not like an expert, and I'm very uncomfortable talking about this. And I look forward to any discussions. I'll just say corrections if I've explained something slightly wrong, or if there's a better way to explain some of the things that I've talked about. I look forward to talking about these in the discussions. It's like I said, I know I have a very tenuous grasp of this. I am at best a hobbyist when it comes to philosophy and Greek philosophy in particular.